Hello, my name is Grandika Primadani, and I'm a petroleum geoscientist from basic Grand Lab Asia. So a bit of background, I enjoy all aspects of geology, but particularly interested in carbonate geology and stratigraphic modeling. So it is an honor and privilege to speak to you in such a memorable event in BFA RDAE soft launch today. So today I'm going to talk about reservoir quality in carbonates, and I have subtitled this presentation to be Exploiting Carbonates of Karst and Production Target. Let's get going. So in this session, we are going to talk about reservoir quality of carbonates, how crucial it is to understand the relationship between carbonate deposition environment and diagenesis. Then we're going to look at the techniques that BFA have established to better understand this multi-scale pore system, which, to be specific today, we're going to talk about Karst using a case study in the central Laconia province. The main reason why we need to address this karstified reservoir is that this repeated exposure and associated diagenetic changes of carbonate platforms have a major impact on the reservoir quality. So Karst may also pose challenges to drilling due to the unpredictable and highly variable porosity and permeability structure of the rock, especially in the carbonates, and the corresponding difficulties in predicting drilling mud rate. So when we talk about reservoir quality here in carbonate, we define it by its hydrocarbon storage capacity and the deliverability. So the storage here means how much fluid can the reservoir hold in terms of the effective porosity, whereas the deliverability means the ability of the reservoir to transfer fluid in a functions of permeability. So when we look into the reservoir quality based on these images, we see that it is mostly controlled by a series of depositional environment. So this beautiful satellite image shows a modern-day carbonate deposition environment ranging from the fore reef to the lagoon. So note that the wind directions and currents are widely thought to be the main factors controlling this carbonate platform facies development. So really understanding the deposition environment is crucial because each of these own set of reservoir quality parameters. So in carbonates, the depositional control affects the initial reservoir quality at the time of the deposition. However, in carbonate, this is not the end of the story. So after the sediments are deposited, a series of diagenetic process takes place. So this diagenesis alters and impacts the original reservoir template that established at the time of deposition to produce what it is at the subsurface. So failure to recognize the presence of Karst or other multi-scale pore system can lead to a significant underestimation of hydrocarbon in place resources. And often this shows by unmatch between the static geological model and the actual dynamic data. So when we look into one unique aspect of carbonate is that its distinctiveness, that is their susceptibility to post-depositional alteration. Just to illustrate that for you, so this is diagram from Fouillon in 2019, showing different types of Karst impacted hydrocarbon fields. But today we're going to look closely onto one of these pore networks. So Karst is one of the diagenetic type in carbonate produced in fader zone, which Fergie connected porosity. So based on this schematic image, there are three broad types of karstification, namely the short-lived, the medium-lived, but really what we are going to look today into closely is that the long-lived or the true Karst that is due to an immersion which generally longer than 100 Ka. So when we talk about Karst development, as we see on the diagram by Warren in 2020, so this is widely known that they are formed during the low stand system tracts. So this low stand system track is in which during a period where sea level is low. So typically this kind of isolated carbonate platform need to grow close to a sea level. So a few meter drop will expose the former reef and the former carbonate of high stands. So to make things even worse, in the tropical areas, there is heat, storm, and rainfall, which is a function of humidity. So that means during the low stand, we can have lots of carbonate dissolution, namely calcification and so on and so forth. So seismic line or image on the left shows some example of this feature. So on seismic data, the geomorphologists exerted on Karst feature in the studied carbonate platform could range from the circular shape with a possible depression, which might be related to a cavern karst. It is observed that the possible karst features are creating karst networks that extend laterally. So some of these karst networks follow the faulting zone and create a vertical network. Again, if related to the hydrocarbon fluid flow, this is quite a crucial factor. So to resolve this complexity, we have to understand the techniques to the carbonate reservoir characterization, especially when dealing with the karstified reservoir, which I have just briefly covered. Now we're going to share our approach in BFA, how we characterize using a specific data set to construct a geologically sound reservoir model. First, of course, we need to understand the data bias and its uncertainty. So predicting the properties and distribution of karst formation is rather challenging and commonly uses the integration of high definition and of course 3D seismic data. So here we present an innovative approach to karst modeling utilizing core and log data, seismic, modern day analogs, and process-based called forward stratigraphic modeling or FSM. So karst observed in image logs in diagram left shows that these are frequently accompanied by a response on other well-bore wireline logs. So typical responses include an elongation of the caliper, suggesting an open space, and also an increase in the photoelectric factors or PF value. In addition to that, decrease in density and increase in total porosity. So with the seismic data, would reveal that some of these karst features have a seismically detectable response called geobodies. So the seismic geobodies allows us to get a sense of karst density and distribution away from the well control. In addition, we propose an advanced stratigraphic model, which combined with the swell and seismic data. So based on our experience, result from this integrated approach that suggests that there is a strong relationship of having karst as shown by exposure time property functions from the 4D space stratigraphic model. So we're going to talk a bit in a few minutes about that. So forward stratigraphic modeling is a numerical and a process-based approach which aims to simulate the evolution of the sedimentary basin or a system in sequence of time step from the past up to present, taking into account the basin deformation, sediment production, and sediment transport. So the general workflow of the FSM approach is summarized there on the bottom diagram, and it is applicable in plastic, carbonate, and mixed environments from continental to deep water. However, in this presentation, we are only going to look at its application in the carbonate setting. So the major input, which includes the subsidence initial bathymetry, sediment supply, compaction law, and carbonate production rates, which in function of water depth as well as the time, and parameters related to water energy as well as the sediment transport, which could be prevailing wind direction, fetch, wave energy, and time length, and the time increment. So these geological parameters have been set, the numerical simulations by simulating and stacking these paleo environments through time and space, thus resulting in a 3D grid of stratigraphic architecture of carbonate system. In addition, the beauty of FSM approach is that it allows us to test the validity of the common exploration assumption or development assumptions, and geological interpretation, as well as the stratigraphic correlation in the picture shown by one of the examples from Central Laconia. So as for the final workflow for this FSM is that the coupling between the stratigraphic modeling and Kruger flow have been tackled seamlessly here. So the idea is this tool would ease the uncertainty and the quantification and the model optimization by offering a systematic and rigorous approach to assess the base case model. Now we're going to revisit a field in Central Laconia where we're going to show a characterization of karstified reservoir found in the Miocene Carbonate. And really the idea here is to perform a comprehensive reservoir characterization. So for your information, this field is a typical cycle 4, cycle 5 carbonates filled up in Laconia, where it is characterized by a steep flank and generally a flat top feature with a thickness around 1.2 kilometers. So the karstic feature here is being very well observable in seismic and related to short-term and long-term exposure event during sea level fall. So with the technology of stratigraphic modeling, the exposure time property being generated from the FSM model would aid the interpretation of this karstic feature. So if we see the bottom image of the seismic, it is clear that the vertical karst features were more apparent in the short-lived exposure events of the micro platforms, which shown by a light blue color, while the lateral karst occurrence were more apparent during long-lived exposure events, shown by the dark blue color. So here, the karst would act as a conduit for fluid flow leaking the continuous facies barrier. So the karst interpretation will greatly aid the dynamic understanding of the early water breakthrough occurrence in this field. So of course, this would help us to optimize the current gas productions and reservoir management. So how we then could relate the success story in Malaysian waters to the Indonesian setting. So we have known that many giant carbonate fields in Indonesia, such as Arun, Natuna de Alpha, Tangguh, and offshore Madura, as well as in Sulawesi, it shows quite similar evidence of non-matrix, which possibly also related to karstified features in geological data sets. So we believe that our success story in the Central Laconia could be a valuable lesson for identification of a karstified reservoir that can also be applied to other fields in Indonesia. So with that, we have come up to the end of today's presentation. So we have seen how the complexity of carbonate reservoirs could be laterally and vertically extensive, and the multi-scale pore system due to genetic processes, especially karst, often lead to the subsurface challenges at both exploration and production scales. So to have reduced this uncertainty, it requires a data integration and integrated workflow with an addition of full stratigraphic modeling. And we have seen how BFA has successfully applied this methodology into a karstified reservoir in Malaysian waters. So understanding this karstified reservoir may assist in the optimization of reservoir performance, reservoir management, drilling strategy, and hydrocarbon recovery. So with that, I thank you again for listening, and should you need any further information or qualification, please do not hesitate to contact us at that email there. So thanks again. Have a great day.